yet another production of the Foundation for Equity and Excellence in Education in Liberia. Today we are going over section G, subsection G of section A of the West African Examination Council Senior Secondary School Mathematics Examination for Liberian schools. Section G covers the topic sets. And in this section of sets, we're going to be solving practical problems involving sets using Venn diagrams. So here are some basic formulas things that we need to know. For any two sets A and B, we can write this representation to represent the number of elements in the union of the set. So NA union B means the number of elements in the union. This means the number of elements in A, which we include, and then this is the number of elements B. Well, these will be the number of elements that are in both A and B. Now, we can extend this concept to like 3 or more sets. 3 sets, for example. So if we have 3 sets, this is what we could do to also be able to find. We can use this to determine the number of elements in any one of these things. Another thing we can do is to make a Venn diagram. So when we have a Venn diagram, I would also love to I can put a rectangle around it, which shows the universal set. So we show you a different representation. These will be the elements in A, intersection in B. So we use a Venn diagram in this case, but we are talking about the actual number of elements. So whenever we see, say for example, if we see a 5 here and we see a 2 here, it means that the number of elements in A will be 5 plus 2. Say we see a 7 here, we see a 2 here, the number of elements will be 7 plus whatever is over there. So you read it as you see it. So one of the ways, this is just a little schematic, some little procedures you can follow to be able to solve practical problems involving this. So you begin with a box representing the universe. Then you decide whether you're going to use 2 ring circles or 3 rings. And then you appropriately label those regions. You find an intersection. And when possible, you want to always begin with the intersection. And then you work your way inside, to the other parts, or outside, I should say. And you can verify your results. So we have problem number 1 here. This is taken from WAEC Liberia 2006. In this problem, so one of the things when you have a problem like this is to basically take your information and put it down so that you can be able to use it. So if Q and R are 2 sets, so we have 2 sets. We have Q and we have R. What do we know about Q? And Q contains 7, so that means you can say the number of elements in Q is equal to 7. And then set R, say the number of elements in R is equal to 5. And we are told here that Q intersect R contains, so that means Q intersect R. That means number of elements in Q and R is equal to what? 2. So they want us here to find, what they want us to find is the number of elements in what? Q union what? R. Now, we can do this 2 ways. We'll use a Venn diagram, and we can also actually use a formula to do, which I'm going to do in both ways, okay? Union R will be equal to the number of elements in Q plus the number of elements in R minus the number of elements in overlap, because you don't want to count for them, double count for them. So let's go back to what we had. The number of elements in Q was 7, the number of elements in R was 5, and the number of elements in Q intersect R was 2. So when we perform this, is 7 plus 5 is 12 minus 2 is going to be 10. So the number of elements in Q union R is actually 10. Now, let's take another approach. And in this approach, you read it as you see it. So we're going to say this is Q, and this is R. So we have 7 elements. So we begin with the intersection. Let's see, how many elements do we have in the intersection? 2 elements. So we have that. Now, Q had a total of 7 elements. Now we already have 2 here. So 7 minus 2 would be what? 5. 5 plus 2 is 7, giving you the number of elements in Q. R had 5 elements. We have 2 here already. So 5 minus 2 would be what? 3. So this is our Venn diagram. So how do we find? This is the entire union. everything in these two shaded regions is union. So we can add it up. 5 plus 2 is 7 plus 3 is what? 10. So again, we see that number of elements in Q union R is equal to 10. Whether we do it by the diagram or we do it by the formula, we still get the same thing. Okay? Now, there are several things that we're going to take into consideration. So let's draw this universal set here first and see if we have enough information or we need to use some rules. So we have two, right? P and Q. So here we're not listing the elements, we are putting the number of elements in. So do we know the intersection? No, that's what they want us to find. Now, we also know that in this entire universe, we have a total of what? 40 elements right here. Now, so this is P union Q, and out here is P union Q prime outside. So, do we know how many elements we have in P union Q prime? Yes, we have 5. So there are several things we know that. We also need to know here, I don't think I indicated that, but here's a very important information. That the number of elements in E will be equal to the number of elements in P union Q plus the number of elements in P union Q prime. And this is going to be our saving information, because number of elements in P union Q prime. And if I go back, I see that the number of elements in E is 40. I see also that the number of elements in P union Q is something I don't know. I don't know the number of elements in P union Q, so I don't know it. So I don't know this. But I also see that number of elements in P union Q prime is going to be 5. So I can solve here for x, and I can find x to be equal to what? 35. So the number of elements in P union Q is 35. Now, let's go back to our problem and see if we can do this. So we can see the number of elements in P union Q will be equal to the number of elements in P plus the number of elements in Q plus the number of elements in P intersect what? Q. That is something, that's what we want to find. Do we know this? Number of elements in P union Q, that's it right over there, 35. If we go back to the previous page, we see that number of elements in P was 25. Number of elements in Q was what? 20. So let's fill them in. Number of elements in P is 25. Number of elements in Q is 20. Plus the number of elements in P intersect what? Q. So if we add this up, we're going to get 35 equals to 45. And I'm sorry, it's not a plus over here. I hope I didn't put plus in the previous video. It's minus. You can understand clearly that it's minus. Number of elements in Q minus number of elements in P intersect Q. So you see this minus here, minus number of elements in P intersect Q. So there's going to be 45 minus and number of elements in P intersect what? Q. You subtract 45 from both sides, you're going to have negative 10 equals negative number of elements in P intersect what? Q. Divide both sides by the negative. So then the number of elements in P intersect what? Q. Be basically what? 10. Now I don't have a lot of space, but I'm going to just right here to show you what we have. So this is what we have. This is P. I'll put P, Q. So now the number of elements we have in P intersect Q is 10. Well, the number of elements we had in P was 25, so this is going to be 15. 10 plus 15 is 25. The number of elements we had in Q was 20, so that's going to be 10. And then the number of elements we had that were not in P union Q was 5. So I'm going to put a 5 here. Remember, we had a total of 40 elements. Let's see what it is worth. 10 plus 10 is 20. 20 plus 15 is 35. 35 plus 5 will give you what? 40. So indeed, it worked. So we had a correct answer, which says the number of elements in P intersect Q is 10. Okay? Now, the next problem involves 3 rings. So let's see how we can do it. We use similar concepts here. Yeah, well, so what do we mean by P intersect Q intersect R? These will be the elements that are in P, in Q, and also in what? R. Now, if we look carefully here, we don't have any element that is in P, Q, and R. So 2 is here, it is not down there. 3, we have 3 in Q, but it's not in P or R. We have, for example, the next number is what? 4. We don't see any out of these 2 sets down here. Then we take 6. We see 6 here, but it's not down here. 5. So actually, the number of elements in P intersect Q equals an R will be what? 0. So again, these are problems that you need to just watch it and keep going back to some of the fundamental concepts, and you should be fine with it. Again, thank you very much. This has been a production of FIELD, the Foundation for Equity and Excellence in Education in Liberia. We are dedicated and committed to providing quality content instruction across all content areas. Our work is being hampered at the moment by the lack of resources. We would really appreciate your contribution and support as we seek to expand our work. Please visit us online at www.fieldliberia.org and make your contribution. No donation is too small. Thank you very much. Please don't forget to subscribe to our YouTube channel, follow us on Twitter, like us on Facebook, and send us your feedback at send us your feedback to fieldliberia2015@gmail.com. Thank you.